Welcome back. Example 4 says find an equation for the hyperbola with vertices located at 0, plus or minus 2 and asymptotes y equals plus or minus 1/3 x. So before we jump into finding the equation, let's plot some of this information on our graph here. So here is my y-axis, here is my x-axis, and then my vertices are located at 0, 2, and 0, -2. Now, I also want to graph the asymptotes, so we know that one of them is y equals 1/3 x, so y equals 1/3 x, we can write that as y equals 1/3 x plus 0, so we know that that goes through the origin, and I'm going to find a point by using rise over run. So my slope is 1/3, which means I'm going to go up 1 over 3. Okay, so there's 1 point, and then I'm going to go up 1 over 3 again, and then now that I have 3 points or 3 ordered pairs, I can go ahead and connect those with a line. So remember, I'm going to use a dashed line since this is the asymptote and not officially part of my graph. Then similarly, I can start at the origin and graph the other asymptote, y equals negative 1/3 x plus 0, and that's going to go down 1 over 3, down 1 over 3, and then I can use my ruler again to connect those. Just want to make sure it's going through the right points. Okay, that's looking better. I don't know how satisfied I am with that. It's supposed to be going through the origin. Okay, but now that I have my vertices and my asymptotes, hopefully it's a little bit clearer where my box is located now, because I know that it has to align with my vertex. So the box is looking like this. And now, if I were to create the graph of this, it would go through the vertices and it would look very wide like this, since it's hugging the asymptotes. So it's going to look something like that. And I'm going to highlight my co-vertices. So there's a co-vertex there and a co-vertex there, and those are located at... Why is my pen so thick? Okay, so one is at 6, 0, and then the other one is at negative 6, 0. And then my vertex, oh, we already know that those are located there. Because our transverse axis is vertical like this, we know from the two options that our equation is going to be of the form y squared over a squared minus x squared over b squared is equal to 1. And we know that the length of our transverse axis, so if I look at the distance between these 2 points, that is 4 units. So length of transverse axis is 2a, And so since we can count the units between those two vertices, we know the distance is 4. If we divide both sides by 2, we know that our a value is 2. And then if we square both sides, we find that a squared is equal to 4. Similarly, if I look at the distance between our covertices, we know that the length of the conjugate axis is 2b. So then we get the equation 2b is equal to the distance between -6 and +6 is 12 units. So then if we divide both sides by 2, we get b equals 6. And then if we square both sides of that, we get b squared is equal to 36. So now we can fill in those values in our equation, and we get y squared over 4 minus b squared over 36 is equal to 1. And the original question is just asking us to find an equation for the hyperbola. So we've gone ahead and accomplished what the original question was asking. So our final answer is y squared over 4 minus b squared over 36 is equal to 1. So I just wanted to quickly show you, I have plotted that equation in Desmos, and notice that we get the graph of the hyperbola that we want, and notice here that our vertices are at 0, 2, and 0, -2, and I could also I can plug in the equations of my asymptotes, and they should align with the graph. So notice that the graph is hugging those asymptotes there. And also remember, the asymptotes are not actually part of our graph. So when you are graphing them on paper, the asymptotes would be dashed lines instead of solid lines. The only real part of our graph are these two portions here. So again, that matches with what we have here, and so that concludes example 4.